impedances of a two-port network. So coming to the iterative impedance of a two-port network, the iterative impedance of a two-port network is the impedance which, when connected to one pair of network, one pair of terminals, let us consider one dash, one pair of terminals of the network produces a line impedance at the other pair of terminals. It is denoted by ZIT. So if you observe this general two-port network, which is terminated with a line impedance of ZIT, then if you measure the impedance at input terminals, that is also equal to ZIT. It's called iterative impedance. ZIT here represents iterative impedance. So in this class, we will discuss about both the image and iterative impedances, and we'll solve some problems related to image impedances and iterative impedance. So this ZIT represents iterative impedance. So this forms the line impedance. Line impedance means if you measure at the input, that is ZIT. If you measure at 2 dash also, that will be equal to the ZIT. So this forms the line impedance. Now let us consider a T network. So here the impedances of T network are Z1, Z2 and Z3. So this forms the T network. So for this T network, if it is terminated with an impedance of ZIT, let us consider this is terminated with ZIT. Then if you measure the impedance at the input terminals, if you measure the input impedance at the input terminals, so the iterative impedance of this T network can be given by, so here Z2 and ZIT are connected in series. So this equivalent is ZIT plus Z2. So this combination is in parallel with Z3. In parallel with Z3. So this combination is Z3 into Z2 plus ZIT, parallel combination of two impedances. So Z3 plus Z2 plus ZIT. So this entire combination is in series with Z1. So finally ZIT becomes Z1 plus Z3 into Z2 plus ZIT divided by Z3 plus Z2 plus ZIT. So this gives the iterative impedance. Now let us determine the expression for ZIT. If you find the expression for ZIT, so we can get the iterative impedance of a T network. Now by cross multiplication, I am writing ZIT terms in one side and remaining Z1, Z2 and Z3 in other side, so that we will get the expression for ZIT. So this ZIT is equal to Z1 into this, I am writing it as Z2 plus Z3 plus ZIT for convenience, plus Z2 Z3 plus Z3 ZIT. So here the LCM is Z2 plus Z3 plus ZIT. So now if you cross multiply and rearrange the equation, we'll get this ZIT into Z2 plus Z3 plus ZIT equal to Z1 Z2 plus Z1 Z3 plus Z1 ZIT plus Z2 Z3 plus Z3 ZIT. We get this expression. Now if we expand this LHS, we'll get Z2 ZIT plus ZIT Z3 plus ZIT square. ZIT square. Now if you see the terms which are there in both the sides, Z2 ZIT is not there in the RHS. So ZIT into Z3 is there. ZIT into Z3 is there. So this is not there. So what is remain here is ZIT square, ZIT square plus Z2 ZIT. This term, if you write in the LHS, will get minus Z1 ZIT. Here already this we have written entire LHS we have written. What is remained here is Z1 Z2 plus Z1 Z3 plus Z2 Z3. So if you write in the other side, this becomes minus of Z1 Z2 plus Z2 Z3 plus Z3 Z1. It's equal to 0. So this forms the quadratic equation in ZIT. So if you find the roots of the quadratic equation, we'll get ZIT is here A is 1, B is Z2 minus Z1, C is minus of this summation Z1 Z2 plus Z2 Z3 plus Z3 Z1. So we know the roots of the quadratic equation minus B. If you write minus of Z2 minus Z1, this is minus B plus or minus square root of B square. B square means Z2 minus Z1 whole square. B square minus 4AC, minus of minus plus 4. A is 1, C is this product summation Z1 Z2 plus Z2 Z3 plus Z3 Z1 divide by 2A. Divide by 2A. A is 1. So we got the expression for ZIT. So there are totally two roots. The iterative impedance cannot be negative. So we need to take the positive quantity. We need to take the positive quantity. So now this ZIT is equal to Z1 minus Z2 divided by 2. I'm writing this minus inside the brackets. So Z1 minus Z2 divided by 2. I will take this as plus square root of Z1 minus Z2 by 2 whole square. I'm keeping this 2 inside the square root. So this becomes 4 inside the square root. So 2 whole square is 4 plus 4 and 4 gets cancelled. So we get the product summation. I will write the product summation as Z square. I will write the product summation as Z square. So where Z square is nothing but product summation. I'm writing this Z1, Z2, Z2, Z3, 4 and 4 gets cancelled. So I'm writing this as Z square, where Z square is nothing but product summation Z1, Z2 plus Z2, Z3 plus Z3, Z1. Now finally, this is the expression for iterative impedance. This is the expression for iterative impedance. Now finally, I can write the ZIT is Z1 minus Z2 by 2. Square root of Z1 minus Z2 by 2 whole square plus Z square. Now, the iterative impedance for symmetric T networks. We know for a symmetric T networks, in terms of Z parameter, the symmetry condition is Z1 equal to Z2. Symmetric T networks. T network Z1 equal to Z2. This is a symmetry condition in terms of Z parameters for a symmetric T network. So if Z1 equal to Z2, this Z1 minus Z2 becomes 0. So we get ZIT is equal to square root of Z square. So here what is Z square? We know square root of Z1 Z2 plus Z2 Z3 plus Z3 Z1. So this is the expression for ZIT. So this is the original expression for any two-port network. This is the iterative impedance of a T network, general T network. So with symmetry, we'll get ZIT is square root of product summation Z1, Z2 plus Z2, Z3 plus Z3, Z1. So this is the iterative impedance of a given two-port network. Now, let us consider image impedance parameters. Is parameters. Now, if you see the definition for image impedance, the image impedance is the pair of a two-port net. This is a pair. Image impedance means image and its impedance. The image impedance pair of a two-port network is such a pair of impedances that when one impedance of the pair of terminals is the output port is terminated with other impedance, that is the input at the input port, input impedance at the input port would be equal to the other impedance of the pair. The reverse is also true. So this pair is denoted by Zi1 and Zi2. So these are the two impedances actually, which are imaged to each other. So if you consider a general two-port network, so this is very simple definition. No need to confuse. So if this is one pair of terminals, if this impedance is Zi1, this is Zi1 when the other impedance, other terminals are terminated with the impedance of Zi2. Zi2. So this pair of impedances is called image impedances. Image impedances. So here the definition, if you see once again, the image impedance is a pair of a two-port network is the pair of impedances that when one impedance of the pair of terminals is the output port is terminated with other impedance. So when the one impedance, here the pair of impedances are Zi1 and Zi2. When output port is terminated with Zi2, then input impedance is Zi1. If the output port is terminated with Zi1, then input impedance is Zi2. That is the reverse. Reverse is also true. So if you see the expression for iterative impedance, of a two-port network. So here the reverse means if this pair is terminated with ZI1 or here. Usually we write ZI1 at the input side. If you write it at the output port also, nothing wrong. So as the network is bilateral, so you can reverse the terminals also. So this will be ZI2. When the input pair of terminals is terminated with ZI1, then output impedance is measured as ZI2. So this is the same definition in reverse manner. So here ZI1 and ZI2 are called image impedances. Image impedances. Now let us consider a T network and let us find out the image impedances, the expression for image impedance. For given T network. So let us consider the T network like this. So this is impedance Z1, Z2, this is Z3. So when this is terminated with, here we have two cases. If this is terminated with ZI2, then this impedance is said to be ZI1. In another way, if this is terminated with ZI1, then this here at these terminals will measure the impedance as ZI2. Okay. Now let us consider the first case only. Now, if you find the input impedance, these terminals. So this is ZI1, it's equal to. Here Z2 and ZI1 are in series. Like in iterative impedance case, Z2 and ZI2 are in series in parallel with Z3. And that combination is in series with Z1. So this entire combination is Z1 plus Z3 into Z2 plus ZI2 divided by Z2 plus Z3 plus ZI2. So now if you take the LCM, ZI1 is Z1 into Z2 plus Z3 plus ZI2 plus Z2 Z3 plus Z3 into ZI2. So this denominator will cross multiply in the next step. Now if you cross multiply and simplify the expression, here ZI1 into Z2 plus Z3 plus ZI2 is equal to. So entire thing will multiply Z1 Z2 plus Z1 Z3 plus Z1 ZI2 plus Z2 Z3 plus Z3 Z3. What is this one? Z3 into ZI2. This is ZI2. Z3 into ZI2. So now if you expand this, ZI1 into Z2 plus ZI1 into Z3 plus ZI1 into ZI2. ZI1 into ZI2. Okay. So now we will consider the second case also. Is there any terms that is cancelled? ZI1 is not there in the RHS. So what we'll do is we'll consider the second case. The input is terminated with ZI1. The input is terminated with ZI1 and the output, if you measure, that is ZI2. From both the equations, to solve two parameters, we need two equations. Two equations. If you solve those two equations, let us consider after simplification, we will consider this as let's write ZI1 terms here only. ZI2, there are two. So this expression will consider. What we are getting here is Z1, Z2 plus Z2, Z3 plus Z3, Z1 plus Z1 plus Z2 into ZI2. Here we are getting, we'll consider this one, ZI1 into Z2 plus Z3 plus ZI2. This is one equation. This is one equation. What is another equation we'll get? We'll get ZI2 equal to the same. If you measure ZI2 equal to what we'll get here is, if it is terminated with ZI1, this T network, ZI1. So we'll get Z3 into Z1 plus ZI1 plus Z2. So what we'll get is Z2 plus Z3 into Z1 plus ZI1 divided by Z1 plus Z3 plus ZI1. So if you cross multiply this also, we'll get the same ZI2 into Z1 plus Z3 plus ZI1. It's equal to this Z1, Z2 plus Z2, Z3 plus Z1, Z3 plus ZI1 into Z2 plus Z3 will get. So by comparing these two equations or by solving, we'll get the expression for ZI1 as ZI1 is nothing but square root of Z1 plus Z3 divided by Z2 plus Z3 into Z square. That is nothing but Z1, Z2 plus Z2, Z3 plus Z3, Z1. We'll get this expression for ZI1. Similarly, what is ZI2 is square root of Z2 plus Z3 divided by Z1 plus Z3, Z1, Z2 plus Z2, Z3 plus Z3, Z1. So we can easily remember what is the image parameter. ZI1 is Z1 plus Z3 divided by Z2 plus Z3 into this product term, that is Z square. ZI2 is Z2 plus Z3 divided by Z1 plus Z3 into this product term. So for symmetric T network, here Z1 is equal to Z2. What we'll get is Z1 equal to Z2. So this ratio gets cancelled. For symmetric T network, Z1 equal to Z2. So this ratio gets cancelled. Now this image parameters ZI1 equal to ZI2 equal to the same as iterative impedance Z1, Z2 plus Z2, Z3 plus Z3, Z1. What about this ratio? Here Z1 is equal to Z2. So this is gets cancelled. So these are the image impedances of a given two-port network of the T network. Thank you.